Welcome to the Phoenix DMA YouTube channel. In this video, we are going to cover the hardware setup, BIOS setup, driver setup, firmware flashing, and common error troubleshooting for our model M100T card. While this video may be specific to our DMA card, it does apply to any 35, 75, and 100T DMA card that uses a CH347 JTAG driver. There may be minor differences, but the majority of setup and usage is the same. All of our products on our website are shipped from within the glorious United States of America. The website is for extended product information and guides. All sales happen on our Amazon store besides pre-owned sales. In our product box, you will find a few items. Firstly, you will have the DMA card itself. On the inside of this card, the FPGA chip is covered by ceramic thermal paste, which is pressed onto the chip by a block inside the card. This paste does not need to be changed, and it is recommended to not remove the case at all unless you intend on changing the paste afterwards. Next, you will have the Phoenix DMA setup USB drive. This will contain all of the needed software, drivers, and test firmware for your setup. The drive contains setup documentation as well in the event that YouTube or the website is not reachable. Next, you have the support card. This contains contact information as well as a QR code that will take you to the website setup guide and this video. Lastly, you will have one USB Type-C 3.0 cable. The ports on the DMA card are not labeled. However, the port layout is the same as any other DMA card. The JTAG port is always the port that will be closest to the motherboard, this being the bottom port. The JTAG is the port you will use when changing firmware, getting your DNA ID, or any kind of back-end change to the FPGA itself. The top port is the data port. This is the port used for normal operations like reading and writing memory. Lastly, on our card, you will have the on and off switch at the very top. To install the DMA card on your motherboard, you will need two additional gadgets. Firstly, a screw for your computer case PCIe add-on slot. These can typically be found on your computer's exterior already. Second, you will need a Phillips head screwdriver. Of course, we are using the latest and newest technology. As you can see, the motherboard used here is a B450 Tomahawk 2. A decent amount of B450 boards do not work with DMA at all. However, this one does. If you would like a list of known good motherboards, check the homepage of our website before doing anything. Turn off the computer and disconnect the power cable. I am aware that the lighting is not so Gucci. For this install, we are going to use the bottom X1 slot for the DMA card. You can use any slot regardless of the size. Carefully place the DMA card into the slot. Doing this should not require any force. It is very, very important that you secure the DMA card to your case with a screw. Very often do we see failures from people who skip this. Anytime your DMA card moves while the computer is powered on, you are doing internal damage to the card. This will eventually lead to the DMA card not working at all. This can also be a fire hazard in some cases. If you have a DMA card that did not come with a mounting bracket, then you should return it or buy a second one, since you will need another one sooner than later. At this point, ensure the switch on the DMA card is in the on position. Plug your computer back in and power it on. Since the BIOS setup is the same, we are going to use footage from our other DMA videos to go through the steps. These changes are only needed on the main PC. My boy Don will take it from here.
Now we will be making some beautiful adjustments in the BIOS of your main PC. This main PC is AMD based, so the BIOS settings in the video will be specific to AMD. However, we will show the settings for Intel as well. For this video, I will be using 200% of my brain power by utilizing the search bar function of my BIOS. If you do not have this function, you will need to consult the manual for your BIOS to find these settings. The first setting to change is IOMMU on an Intel system. This setting will be virtualization or VMX. This setting needs to be disabled. The next setting is SVM. On an Intel system, this setting will be VTD. This setting also needs to be disabled. Those are the only two BIOS changes needed for your DMA card to operate normally. There are other BIOS settings that can be changed for specific applications that will be covered in the troubleshooting portion. Ensure that you save your changes, then boot into Windows.
It is difficult to see in the video, but there are 3 status lights on the card that are important to understand. The red light on the bottom represents power to the card. If the card is on, this light will always be on and will always be red. The bottom green light only comes on while you are reading memory. This includes while you are running a speed test, which we will do later. The top green light represents a successful PCIe connection. This light will typically flash as soon as you turn on your computer and then go solid. Out of the 3 lights, this one is the most important. It can save you the most time while you are troubleshooting with your provider if you are able to communicate what this light is doing to them. For the rest of this video, almost everything will be done on the secondary computer, including this part. As you can see, I have my side piece posted up on the wallpaper, and we're ready to get this going. We are going to be using the included flash drive for all files. If you don't have the flash drive, then you can download these files on the Model M guide linked in the description. To make this easier, we will extract all the files to the desktop. Start by extracting the 3.1 Microsoft Visual folder from the zip archive. You can extract this anywhere. Go into the folder and run the install all bat file at the top of the folder. To avoid getting 20 different yes or no pop-ups, you can go into your user account control settings, turn user account control off by dragging the bar to the bottom and clicking OK. Once finished, the command window will close. Next, we will move into installing the JTAG driver. Using the provided USB cable, plug your secondary computer into the JTAG port on your DMA card. Next, go into the JTAG driver folder and extract the CH347 folder to your desktop. Open Device Manager to ensure your JTAG is connected. For our Model M, you should have the JTAG in other devices with an error as well as a device in ports. You may not have the same devices if you have another DMA card, but something new should show at least in either the ports or other devices menu. Next, go into the CH341 PAR folder, run the setup application, and click Install. Go into the DVR Setup 64 folder and do the same. Now the error device from before will move to the interface menu with its new driver installed. That is all for the JTAG driver setup. Since we need to still be in the JTAG port for the next few steps, we will come back to this folder when it is relevant. Now we are going to move into firmware flashing. As mentioned in previous videos, we do not validate our cards with or provide support for any custom firmware. You can still flash your DMA card the same way, but if any issues come after the flash, you will need to seek out to whoever made the firmware for support. Go into the firmware folder and open the CH347 FPGA tool archive. Extract the CH347 FPGA tool folder to the root of your C drive. Run the CH347 FPGA download tool application. Open Device Manager and verify that you are in the JTAG port. At the top, select 100T for the FPGA, bin for the middle, and leave the last drop down how it is. Use the top left button to select your firmware file. We are going to use the included base firmware for this example. Whatever firmware you are using, ensure that it is either in this folder or in the root of your C drive. Click the middle left button to begin the flash. My secondary computer was absolutely bugging. We are going to do the flash on a different computer for now so that it can be demonstrated. Once complete, you will get a message similar to this. At this point, do what is on the screen. If you had issues with the other flashing methods, such as looping or any kind of error, you can use this next method as an alternative. Otherwise, if everything went well, then you can skip this part of the video. This next flashing method is a little more than just clicking a few buttons. We will try to walk you through it as much as possible. Go into the firmware folder and open the 1.2 manual flash archive. Navigate to the root of your C drive and extract the archive there. Locate the firmware file you want to use. For this example, we are going to use the base firmware on the flash drive. Put this file in the flash script folder in the root of the C drive. If you cannot see all of the files like in the video, click the View menu. Then make sure the Hidden Items box is checked. Open the flash CH347 100T.cfg file in Notepad. All you need to do here is ensure that your .bin file is defined on the JTAG program line. Make sure the file name in the CFG file is set to the same file name of your firmware file. Next, open Device Manager and ensure you are plugged into the JTAG port of your DMA card. Double-click the flash CH347 100T batch file to start the flash. I bottlenecked my second PC on purpose to demonstrate this issue. If you have a lower performing second PC and you try this method, sometimes the script will output 0 and 1 milliseconds for every sector. This is not a successful flash. Your DMA card will not work after reboot if you stop here. To fix this issue, you will need to close the command window and reopen it until the milliseconds display a number in the 200 range for each sector. As long as the script went through every sector without any issue, you can ignore the failed message at the end. At this point, do what is on the screen. Now we are going to move into the DMA Speed Test. I have this computer on a fresh Windows install to make the video relatable. My DMA card is now plugged into the second computer via the provided USB cable. Sometimes the driver for the FTDI will auto-install. Luckily for me, it didn't, so I can demonstrate what to do in that case. Go into the data driver folder and run the application for the driver installer. Once installed, you will now have the FTDI bridge device installed under the USB controllers menu. Now go back to the firmware folder. Open the FPGA DMA test archive. Extract the FPGA DMA test folder somewhere. Run the lone DMA test application and then press 1 on your keyboard to start a full test. If you are reading good or excellent on your speed and throughput, then you are good to go as far as reading memory goes. Lastly, you will need to verify the firmware is showing on your main computer. For the baseline firmware, it will show as an Ethernet controller with an error under Other Devices in Device Manager. This concludes the setup for our model M100T DMA card. Since the troubleshooting procedures from our previous videos are still valid currently, we are going to reuse footage from those videos to cover the troubleshooting portion of the video.
For the troubleshooting portion, we will mostly be covering common DMA speed test result errors and how to resolve them. These scenarios are put into the video in a specific order on purpose, and it is recommended to do the steps in every scenario, even if your issue is not the one actively presented. Before doing anything, go back to the firmware flashing part of the video and flash PCI leech-based firmware to your DMA card. It is recommended to do any troubleshooting on base firmware. It is highly wise to ensure you have a .bin file copy of your Cool Guy firmware before reverting back to PCI leech-base. If your GigaChad firmware seller did not give you this initially, then they probably will not on request, and any issue you have, they will be responsible for fixing. It is hard to determine if an error is caused by your 1 to 69 Gunner firmware or something else if you have not validated your DMA card on base firmware. The first common error is the VMM, and it failed with all zeros in the device error. This error is almost always due to your data connection not being seen by the test tool. To verify your data connection, right-click on the Windows icon and open Device Manager. To produce this error, I currently have my second PC plugged into my JTAG port on my DMA card, as you can see by the USB serial device under the port section. In some cases, you may have your second PC plugged into your data port, but you are not seeing the FTDI bridge device in the USB section. If this is the case, first make sure that your DMA card is not kill switched and the lights are on. Second, find another USB cable to use. Please give me a moment while I switch the USB cable to my DMA card's data port. As you can see, the FTD bridge device is now in my USB section in Device Manager. Now we can run another test and see if we are goning. If you have done these steps, but you are still getting the error, follow the steps on the screen and try a speed test again after. If no worky, you can continue the rest of the guide, as the other scenario fixes may help as well. The next scenario is the VMM and an error but with non-zeros in the device error. This is commonly caused by misconfiguration of the BIOS on the main PC or by Windows settings that can be conflicting on the main PC. Here we are back in this absolute beast of a machine, main PC BIOS. I have intentionally reverted the required virtualization-related settings to produce this error that I will now change back. Then we will cover some other settings that can be useful to change. The first additional setting will be NX mode. This is generally on AMD-based systems. This setting needs to be disabled. In some cases, NX mode will not show in search but can still be found within the BIOS settings. In my case, the setting can be found manually in the advanced CPU configuration of the overclock settings. Please refer to your BIOS manual to ensure you do or do not have this setting. The next additional setting will be CSM mode or CSM support. This setting needs to be set to either enabled or CSM. The final setting will be fast boot and fast memory boot. This setting needs to be disabled. If you have both settings, then disable both of them. Here is an overview of all of the changes just made. Some of the settings here automatically change just from changing the CSM setting. Save these changes and then boot into Windows. On our main PC, we are going to verify that we do or do not have memory integrity. To do this, open the Device Security Settings page. My system does not have the core isolation section, which is what memory integrity is in. Instead, I will show a picture of what this setting looks like. After checking this setting, you can reboot the main PC and then try another speed test once the main PC is turned back on. At this point, if you are still unable to run a speed test, you can reach out to us on Discord regardless of what DMA card you have, and we will help you. The next scenario will be a low-performing speed test and tips on how to identify the root cause and correct the issue. With this speed test result, take note on how both the read speed and the throughput speed are underperforming. Most DMA cards, regardless of 35 or 75T, will perform in the 5,500 to 6,000 plus range for read speeds and 190 to 200 plus for read throughput. When both read and throughput are underperforming, this is almost always an issue with the cable being used from the second PC to the DMA. Instead of guessing and going through cables hoping for the next one to work, I will show you how to verify this. The software we are going to use to verify the USB cable is called USB Device Tree Viewer. Go onto their website and download this software and extract it from the zip file to anywhere. Then run the software. Within USB Tree Viewer, find the FTDI device. Take note of the USB version, port max speed, device max speed, and device connection speed. I am using some random cable that I found on Air Force One, and it turns out that it is a USB 2.1 cable instead of a USB 3.0 cable. The FTDI interface on the DMA card is a 3.0 interface. So your cable type and USB port on the second PC need to be at least a 3.0 in order to have a healthy connection. Please stand by while I switch this trash AF cable for a 3.0 cable. As you can see, this new cable goes hard AF. The USB version is showing 3.1 and all of the speeds are showing super speed. At this point, my DMA speed should be hitting, so let's check. The DMA read and throughput are now reading at a passing rate on the 3.0 cable, as you can see. This next scenario I was not able to replicate on my system, so I am using a customer image instead. This issue is very common, especially on custom firmware applications. Like every other scenario, we are only covering what to do for base firmware issues. This issue is specific to having stable read speeds, but being locked to a 10 to 40 megabyte per second throughput speed. To troubleshoot this, you will need to do everything in the previous scenarios as well as change a BIOS setting. In your main PC BIOS, search for the term PCI. For my system, the setting I need to change is the PCI Gen switch. The name of this setting may vary, and you may need to refer to your BIOS manual to find the correct setting. The most thorough method for troubleshooting this issue is to start with the Gen 1 option. Set the Gen switch to Gen 1. Save your BIOS and boot windows. Do a DMA speed test. If your results did not change, go back into your BIOS and go to the next gen setting and so on until you had tried all. This concludes the setup and troubleshooting video for our 75T DMA card. If your issue was not solved here, please reach out to us on Discord. We do also provide support to non-customers, but please understand that customers will always have priority for support.